436. Find the right interval. First, let's try to understand the question. So we are giving an array of intervals, so this is easy to understand. It with the start I and end I. So for each of the index I, it has a start and end. Yeah, and each start I is unique. So this means the values like the start, like 3, 2, or 1. So those kind of start are unique. It means there is no duplicate. So the right interval for an interval I is an interval j such that start j more than or equal to end I, and start j is minimized. Yeah, this is the very important part of the problem. You need to understand it. Yeah, note that I may be equal to j. So yeah, you need to consider that I may be equal to this j. So what does that mean? So for example, we have an array of intervals. Yeah, let's try to prepare a longer intervals. Yeah, if we have intervals like this, so what about the first one? This is 3 and 4. We need to find another interval. So the start value of the other interval is more than and equal to this 4. We cannot find that, so we're gonna get a -1. And for the second one, 2 and 3, we need to find an interval. So this start value is 3. 3 is more than and equal to this add value 3. So we're gonna return 0 because the index is 0. And then we're gonna check this one, the last one. So we're gonna find a 1, but this one gonna be minimized. 3 and 4, 3 is more than or equal to 2, but this 2 is also more than and equal to 2. We're gonna find this 2 because this 2 is minimized. So we're gonna return a 1 for the final index. Yeah, as you see, this is a typical sorting problem. You have to sort it first. After that, it's gonna be easier. So for example, if we sort it, but if you sort it, you're gonna lose the information about the index. So before you sort it, you should also put the index inside, and then you're gonna have the information of the positions of each start and end value. So for example, the first position index 0, and then index 1, and then index 2. We're gonna put it at the end of the array. Now we are going to sort it according to the start position. So the start is 1, and then because it is unique, so it's gonna make the problem easier. So here is unique, and this is another start, and we're gonna put it here. So we're gonna put it at the end, and then we can calculate it. Yeah. So for the first one, so this is 1, 2, 3. 3 is the index. It doesn't matter. So it means we're gonna also prepare an array, result array, or the answer array. So from the beginning, it's gonna be -1 and -1. So for the first one, yeah, we're gonna check the first one. So this is a 1 and 2. So this is the end. It's 2. We're gonna find the start value, which is more than and equal to 2. Normally, as you can see, this start value is always more than 1 because it has been sorted. And if this value is more than and equal to 2, we get the index. So here the index is 1, but the position for the index, it is I'm sorry, it is not 3, it is 2. Yeah, because it is 0, 1, 2. So at the position of the 2, I will get an index of 1. And then I'm gonna check the second one. Yeah, for the second one, I'm gonna check which value is more than and equal to 3, which start value. So this start value is more than and equal to 3, so the index is 2. So from here, so the index is 0, as you can see, it is 0. Yeah, so for the index 0, I got a value. I think I got confused. Yeah. Let me try to do it again. So here, the first one, it is okay. Let me do the second one. So the second one, currently the index for the second one, it is 1. Yeah. So what is the value which is more than and equal to this 3, the start value? So it is here. Yeah, it is at this position. And what is the index? So it is 0, right? So it means at this position index 1, I'm gonna have a 0. Now let's go to the last one. because there's no array after the current array, so I gonna get a -1. So this is the result. I hope you understand the process of solving the problem. Now let's just start coding. The coding would be exactly like what I explained. Yeah, basically we need to sort the arrays. After sorting, we're gonna use the binary search to search the places. So the time complexity will be n log n. Otherwise, you're gonna get time limit exceeded, I believe, because this n is 2 times 10 to the power of 4. If it is n squared, I believe it will got time limit exceeded. So it will be n log n for the time complexity. Yeah. Now let me just prepare the sorting part. Yeah. So I'm gonna prepare a result array. It will be empty. So for start, I gonna enumerate. So for I start and enumerate the intervals. Yeah. And then I'm gonna put it inside of the result. I will put it array. I think array and tuple are the same, but I will put it array inside of the result. So first index gonna be start, and the last one would be the index. Yeah. Now we have a result array. So I'm gonna sort the result array according to the start position. The start position is index 0, so I don't need to do anything because by default this sort is by index 0, and this index 0 is also unique, so I don't need to do anything about it. Now I'm going to prepare a variable n. It will be length of the intervals, and I'm prepare an answer. It would be -1 times n, and finally I'm going to return this answer. Yeah. Now let me put it like this. So I'm going to get the answer array, but how can I get it? I can use this result array. Yeah. So for start and index in result, we can use the binary search directly. So I can check the index. So this index would be equal to bisect left. Let me explain why I use the bisect left later, but let me first finish this line. So I'm gonna check the result array, and I'm gonna check the numbers. It is the end. Yeah, this e, it is the end. And I'm gonna use a lambda function to check which position I'm going to sort the array. So k would be equal to lambda, and x should be equal to x. So currently I'm using the bisect left according to the first index, because this is a nested array. I have to use a lambda function to check at which position it is. So I'm going to use the lambda function to make it as the first position. Otherwise, you cannot use the bisect left. Yeah. Yeah. But before that, let me just print out the result first. Yeah. Let's just check the result. So let me just print out the result. Yeah, because I'm going to use this example to explain. So I'm going to use this result as my example. So I'm going to put the result here. Yeah. Now we are going to check this line. Why I going to use this line? Yeah. So this is my result array. So for the first position, this is my start 1, add 2, add index 2. So I'm going to use the bisect left with this result array. And I'm going to check the first index. Yeah, I'm going to use the binary bisect left according to the first index, but I'm going to check the value of 2. Yeah, so by binary search, I'm going to find the position of the number, which is 2. Yeah, which is this number, this 2 is more than and equal to my end position 2. So it means I've already found it, so the index is 1. And then I'm going to put it outside inside the answer array. So the answer array index is 2. Yeah, as you can see that the answer array, the index is 2. Yeah. So here is basically some calculations. You need to check that. But I need to check this index first. This index should less than n. Otherwise, it's gonna be -1. So I have to check the index. Otherwise, the index will be out of the boundary. Yeah. So if this index is let's say n, I got an index j, so this j would be equal to the result index with the third position, it is the index 2. So this means from here, I'm gonna find the index. This j should be equal to 1. So I can get the answer array. So the answer I should be equal to j. So the answer I is 2. So the answer I, this position, I will got a 1. So this is exactly what I explained about everything. And the process is not so difficult. You just need to understand the process of sorting. And we have to use some kind of a library to save time. Because if you're going to use try to write a bisect left for yourself, and it is also a nested array, you're going to make mistakes, and it also takes more time than you expected to finish this problem. But as you can see, if we know the bisect left and know how to use it in a nested array, it's going to save us a lot of time. Now let me run it to check. Yeah, I hope it works, but let's just check. Yeah, at the same time, let me check my code. So basically, this is the result. It is okay, start, end, and after sorting, I got an answer array, and I put the result inside the answer array. If it is not inside, it will be by default, it will be a -1. Yeah, it didn't work. I have to refresh and submit it again. Yeah, it seems it really takes a long time. Let me refresh and submit it again. Yeah, this is I believe it is the network problem. Yeah, let me first run it. As you can see, it works, and now let me submit it. Yeah, as you can see, it works, and it's pretty fast, and the time complexity is just the sorting. As you can see from here, we used a sorting, so the sorting is the n log n time. Yeah, after sorting, we checked for each of the elements inside of the result, and for each of the result, we also used the bisect left. So this time complexity is also n log n. So the final time complexity is n log n. Thank you for watching. See you next time.